All right, so in the last two classes, we have already talked about the whole contents of chapter one, which is just the introduction about the data, the introduction about what is statistics, what is business statistics, right? So once you have a data table, then you need to know that the rows will be the cases, the columns will be their variables, right? And then we have two major types of variables, which is the qualitative variable and quantitative variable, right? So qualitative variable, we also call it is categorical variable because your responses will belong to some categories, right? And if the responses are numerical values with units and they are the measurements of some contents, then it will be called quantitative variable, right? So don't get messed up. So today I'll just since we are using the jump, so I think it is good idea for you to practice with some simple steps for the jump, right? And when you click this module, you should able to see this get started module, right? I believe most of you have already reviewed these pages. And today I will just go through these jump introduction videos with you, and I covered several topics until the end, but today I think I will just go through several of them so that you have some general idea about what the jump can do, right? And how to start it with it, right? So for example, how you can import the data to the jump, how you can do simple analysis about the data, right? And then for the data type, how we can identify what is the data type in the jump, how we can make sure the data type in the jump is they are right. All right, okay, so let's go through a general introduction of jump, right?
In this session, we cover basic navigation and use of JMP statistical discovery software from SAS. We'll cover JMP menus and data tables, the JMP interface, and summarizing and graphing data in JMP. We'll use JMP.
So this video is actually give you a big idea about what JMP can do. But for this course, for ISA 125, you may not need to use many of the feathers this video introduced. But it is a good idea for you to get a general picture about this software. It's not just limited to our course. You need to know that what the jump can do in the future. All right. Okay.
JMP on a Windows machine, but JMP also runs natively on a Mac. We'll use a JMP journal during this session. In this JMP journal, I've added links to JMP data tables to make it easy to open and access data files in JMP. These files can be found under the Help menu in the Sample Data Library. If you're not familiar with JMP, here's a quick peek. JMP provides a wide variety of graphing and analysis options. This is the Graph Builder, an interactive graphing platform.
All right, so for this part, I will introduce about this part later. But now you don't need to be nervous about how to use it. You just kind of watch a movie, see how fashion it is, right? So what kind of fashion graphs it can produce? It is beautiful. It looks pretty. They are colorful and very interesting, right? So just feel interested in this software first, all right? And then in the future, I will introduce how to generate these kind of graphics, all right?
Drag and drop variables to different zones. select Icons from the palette and change options on the side. In the background is a data table, which contains columns and rows. We'll revisit the Graph Builder and see other methods for graphing and analyzing data in a few moments.
Okay. All right, so when you look at this table, you should know that it is the same setting as what we learned in the lecture, right? So we need to make sure that these rows are the cases, right? And then these ones, these columns will be the variables, which are the characteristics of these cases of these students, right? So the picture of this student, the name of this student, the age of this student, sex of it, height, weight, and something other characteristics. So when you import a data table, you need to make sure that the rows are the cases, the columns are the variables. If not, you need to change the setting of the table so that you can have the right analysis. Otherwise, if you flip these two directions, then you will have totally different analysis result, and then your result is not right, totally wrong. All right, okay.
And see other methods for graphing and analyzing data in a few moments. When you first open JMP on a Windows machine, you'll see a home window. The home window makes it easy to see recently opened files and to navigate between open windows. You'll also see a Tip of the Day window. The Tip of the Day window gives shortcuts and tips for navigating in JMP. Let's talk for a few moments about the menus in JMP. The File menu includes options for opening and closing and saving work in JMP. You'll see options for connecting to databases, including a query builder, for connecting to SAS, for importing datasets from the internet, and also for setting preferences. On a Windows machine, one preference you'll want to set is under Windows Specific, Auto Hide Menus and Toolbars. We'll change this to Never to make sure your menus appear on every window. When you make a change within Preferences, click Apply to accept the change, and then OK. Let's talk about data tables.
All right, when you watch this video, try to follow this video in your own JMP and then follow these steps. Make sure that you can do everyone. All right.
Tables in JMP. We opened the big Class Families dataset. The panels on the side tell us a little bit about our data. And a data table in JMP is columns and rows, where within each column we have the same type of data. The top panel is the table panel, where we can save notes and references, and we can also save the keystrokes to recreate analyses. JMP's programming language, JSL, makes it easy to save and share work within JMP. The columns panel tells us about the columns or the variables in our data table. This data table has 12 columns, and one column is currently selected. The rows panel tells us about the rows in our data table. This data table has 40 rows, and 2 rows are currently selected. To deselect columns or rows, click below the diagonal in the top corner of the data table, or above the diagonal in the corner of the data table to deselect columns. The icons next to the variable names are the modeling types for the different variables. Click on an icon to see the available modeling types. The 3 primary modeling types are continuous for numeric data, where calculating an average might make sense, ordinal for ordered categories, and nominal for categorical data, or labels. A new category is none. Additional modeling types include multiple responses. For example, siblings. This is a survey of students. Sibling ages indicates, for example, that the first student has 2 siblings aged 1 and 5. Unstructured
All right, I need to stop here a little bit. All right, so when you input your data file or import your Excel into JUMP, the first thing you need to do is to check the variable type in the left here. All right, so for every variable, for example, the last one for the name and picture of this, right? So since picture doesn't provide any information, you cannot do analysis about it, right? So it just give a different picture for each case, for each student. Then what? Then this variable is actually a identifier variable, right? So it is not ordinal, it is not nominal, it is actually not these ones, right? It is not quantitative variable, right? So for this case, if it doesn't show none, then you need to right click of it and then choose the right type of variable. Otherwise, the JUMP is not that clever. The JUMP just defaultly say, okay, if there is any text in the column responses, then it will be belongs to nominal or ordinal. But if there is a number, it doesn't matter this number is zip code or the age, they just assign it as the quantitative variable. All right, so be careful. You need to identify these variables first before you do any other analysis. Right, so again, for the name, it's just a name for this person, for this student, right? So this name should be identifier again. It is not a categorical variable. All right, got an idea? Okay.
Of students, sibling ages indicates, for example, that the first student has 2 siblings aged 1 and 5. Unstructured text is simply text data. So if I scroll over to reported illnesses, we see text with no apparent structure. And another new modeling type is vector. JUMP will use the modeling types when determining the type of analysis that makes sense. A little bit more about our data tables. Within each column, we can specify column properties and column information. If I right-click on a column, go to column information, we can change the name of the column, the data type, the modeling type, and also the format displayed. We can also specify column properties. Let's return to our journal and talk about summarizing and graphing data within JUMP. I'll use the U.S. demographics data to talk about different ways to produce numeric summaries, also graphical summaries of our data. U.S. demographics includes information on.
All right, so if you want to practice with the video, right, if you want to have this data set for practice, how you can find it? Go to your JUMP, all right, and then what? And then remember at the beginning of this video, it says in the help, there is a sample data library, right? Click that, right? You will have many sample data. It is called the sample data library. So let's see our video used US demographics, right? So let's search for it. So help, sample data library, and then it starts with EU, right? So just go down, demographics, yeah, that's it, right? So click that, you will have this data set, and then you can follow the video's steps to do whatever you want to practice. All right, so I just want to show you where to find this data.
The states, household income, IQ, region, and other demographic characteristics. To quickly summarize all of the variables in a data set, we go to Columns, Columns Viewer. Columns Viewer allows us to select all of the variables and show summary information. I'll select Show Quartiles and then Show Summary Information. For each of the variables, we see the number of observations, the number of missing observations. I'll hit Clear Select to deselect the variables. For categorical variables, we see the number of categories, the mins and the max and mean and other statistics are displayed for continuous variables. We also see median and the quartiles in the interquartile range because I selected Show Quartiles.
We will talk about these quartiles later, in chapter 2. So don't worry about it. Just look through this video and see what kind of good things they can do. All right, okay. So here I think I need to explain a little bit. Let's look at our data. All right, so this is the data, and then go to columns and then column viewer, and then we select all the variables and then show the summary of these variables, right? And then you will see N. Normally we call the capital N as the total number of observations, right? So that means there are totally 50 observations in this variable, right? So that means these rows are totally 50 of them, all right? And then this one, see N missing. So that means total number of observations that are missing. All right, so let's do an experiment. For example, for this Arizona state, for the household income, the information is missing. It's nothing here. All right, so it will show you a black point here. Right now, if I do the columns in columns viewer, and then choose these ones to show the summary, and then you will find that for the household income, for this variable, you see, for this variable, the total number of observations will change to 49 because what? Because I have one number of observations that is missing. Got the idea? All right, so this variable, actually this category, it tell you how many observations are missing in this variable. All right, okay, and then for N categories will be total number of categories. All right, so it will only show the numbers for categorical variables. So since the state is the categorical variable, and what the region is the categorical variable. So it will show that in this variable, in the state variable, how many categories included in this variable. And for the region, you have the southwest, northeast, and middle west, and something like that. So totally for the region, you only have 4 categories. All right, so it will give you some summary about each variable. It is very, very important for you to learn about the whole data table. All right, okay, now let's come back to the video.
This gives us a first peek at our data, and from here we can look at issues such as data quality, or missing values, the range of values, and any potential data coding issues we might have. If we're interested in both numeric summaries and graphical summaries, we use the first option under the Analyze menu, Distribution. Distribution is for producing univariate graphs and statistics. From here we can select the variables of interest. I'll select the first 4 variables other than state and select Y columns. Recall that the icon indicates the modeling types for the variables. JMP will
Alright, so here you see how it is important that you need to make sure the rows are the cases and the columns are the variables, because what? Because when you need to produce some graphics or distribution analysis for the variables, these names are the variables name. Right, the system will choose the column's name as the variable's name, and then if you choose the variable's name, defaultly it is Y with the column names. That is why it is called the columns. But if you switch the order of these two, then everything will be messed up. Then the names here will be the cases, maybe the student's name, something like that. It is not a real variable name.
determine the correct type of analysis based on the modeling type that's been specified. By default, for continuous variables, we see a histogram, box plot, and summary statistics. For categorical
We will talk about this part later in the chapter 2.
variables, we see a bar chart and frequency distribution. To change the layout, under the top red triangle, select Stack. This is also a preference that can be set.
Stack function is actually change the direction of the graph so that it is easy to see it. Because if it is vertical, it is not easy to see the distributions. But now everything looks normal, at least, right? So stack function is also very important when you provide me the conclusion or the report in the future projects, right?
To display additional summary statistics, click on the red triangle and select Customize Summary Statistics. A wide variety of other summary statistics are available. Additional options are available under the red triangle. The options that are available depend on the modeling type for the variables. For continuous variables, we see options such as normal quantile plot, hypothesis testing for the mean or standard deviation, and the ability to fit different distributions. For categorical variables, such as region, we see display options, histogram options, and the options are updated based on the types of analyses that are available for categorical data. Now, if we're simply interested in numeric summaries of our data, we use Tabulate. Tabulate gives us a drag and drop palette for summarizing our data. I'll select household income, and as I drag over the zones, notice that the zones are highlighted in blue. This indicates that we can release the variables in these zones. By default, we see the sum for the variable that's been selected. I'll drag and drop region to the other zone, which is now a small box. To change the summary statistic, we select statistics from the list and drag and drop. If I drop on top of the numbers that are already displayed, JMP includes these two statistics in addition to the one that's already displayed. I'll click Undo. Instead, if I drag and drop on top of the statistic that's already displayed, JMP will replace this statistic with the selected statistics. To add additional variables, drag and drop. Let's add state to this analysis. I'll drag state to the front end of region, and JMP summarizes first by state and then by region. I'll click and drag and move state, and now the summary is by region and then by state. To save your work, click the Done button. Tabulate produces numeric summaries. Graph Builder produces graphical summaries. So I'll click and drag household income to the Y zone. And notice as I drag over different zones, different summaries are provided. The blue box indicates that we'll get a sneak peek at the type of graph that will display if we release the variable in the particular zone. I'll release household income in the Y zone and region in the X zone. The ribbon across the top is graph elements that we can add to the graph. If I click and drag on a graph element, this adds the graph element to what is currently displayed. If I click on a graph element, the existing element is replaced by the new one. Additional options are provided on the side for the graph icon or graph element that has been selected. The Start Over button allows us to start over. To plot a continuous variable against a continuous variable, options such as linear regression and correlation are available. For a continuous variable against a categorical variable, options such as bar chart and box plot are available. If we have geographic data, for example, state in this case, we can drag the variable to the bottom zone, the map shape zone. JMP ships with shapefiles that allow us to create a geographic map of the data. I'll drag and drop a variable on top of the graph or in the color zone, and the graph updates. The colors indicate the household income
for this part, I will now require you to do this kind of thing in RSA 125, but I think it is a good idea for you to get a knowledge about JMP, that the JMP can do so colorful things, right? So you have already seen this kind of graph when the COVID-19 happens in United States, right? Something like this. So actually JMP can generate this kind of graphic very quickly. Once you have the data, the graph is already there.
for a particular state. Click the Done button to produce the graph. JMP includes a variety of tools for exploring other variables. Click on the red triangle. Local Data Filter allows us to update this graph based on categories for particular variables. So for example, if I select region and click Add, I can select different regions and the graph automatically updates. A second tool for updating the graph is the column switcher. Under the red triangle, Redo Column Switcher allows us to swap out variables with other similar variables. I'll use the Control key to extend the selection. I'll minimize the local data filter, and as I scroll through the column switcher, notice that the graph automatically updates. If we want to explore the relationship between continuous variables, under the Graph menu is the scatterplot matrix. The scatterplot matrix allows us to select a number of continuous variables and explore potential relationships between the.
For this part, we'll talk about the correlation and linear regression in chapter 4, right? So just for now, you just get a general idea what is that, yeah, right? And then I don't have any work for you or computer lab for you, just to give you a general idea about JMP.
Finally, if we're working with categorical data, where we might have typographical errors, so for example, if this were typed out south, instead of abbreviated as S. To be able to work with categorical data, we can clean the data first. Under Columns, Recode is an option to recode our data. We see the original values, and we can add new values. So South and South should be grouped together as S. I'll select both values and click Group, and now South will be recoded as S. To save my work, I can either override the existing data or create a new column with the recoded data, or create a new column with the formula to clean up potential data we might add to the data table in the future. This creates a new column, Region 2. This concludes Basic Navigation and Use of JMP Statistical Discovery Software from SAS, Part 1.
Alright, so this video just give you a general overview about JMP. The next 3 videos will talk about how to get started with JMP. Alright, so be sure on the your modules, right, and in module 1, and I upload this Excel file, which is organics. Right, so you will use this file for your project 1 and project 2. So I think it is better idea for you to go through it and then just study about the variables first before you do the project 1. Right, so first download this organics Excel file, and then let's watch this video and see whether you can do similar things followed by the steps the video provided. All right, okay.
In this video, we're going to talk about opening JMP and getting started. When you first open JMP, you'll be greeted with the tip of the day, which provides helpful hints on using JMP. From here, you can start the beginner's tutorial or scroll through other tips if you're interested. Behind the tip of the day, you'll have the JMP Home window, which shows you a listing of your recent files and available open windows. Behind that, if you're on a Mac, you'll see the JMP Starter. If you're on a PC, you can launch the JMP Starter from Window, JMP Starter. The JMP Starter window provides shortcuts for using JMP, including opening files and access to many of the analyses available. To make a new data table, we'll use File, New Data Table, which will open a blank dataset with 1 column. You can add additional columns by double-clicking in the spaces, and you can type in data by clicking within any of these columns and entering a value. We can open a dataset in JMP by going to File, Open. JMP can open many different file types, including JMP files, Excel, SPSS, and SAS files. To get more help, the Help menu provides access to a wealth of materials, including the built-in JMP help, the Books menu, including several different books on using JMP, including all the details of advanced analyses, a new features listing, and several tutorials to get you started. Many of our videos reference sample data, which is available under the Help menu under Sample Data. Sample data includes access to categorized datasets and also the original sample data directory, which will show you all the available sample data files included with JMP. In this video,
Alright, so this is just a short video about the how to get started with JMP. Right, next video is tell you how to import data from Excel.
In this video, we will see 2 methods for bringing in data to JMP from Excel. I'm using the big class example dataset that's available under the sample data directory in Import Data. Our first method is to use JMP directly to open the Excel file. I'll switch to JMP, go to the File menu, and select Open. Here, I'm in the Import Data folder, which is available under the sample data directory. I'm going to find my file, it's called bigclass.xls, select it here, and simply click Open.
Alright, so since we do not have his file, his Excel file. Just use the organics Excel file I upload on the in the modules, and then try to practice with the steps he did and see whether you can produce the same thing, whether you can import the organics Excel file into JUMP.
JUMP will open these data directly, and on the basis of the values in each column, decide the modeling type. Notice that for any column that stores text, JUMP has predefined this column as nominal. Any column that only stores numbers will get defined as continuous. Be careful of the modeling types that you bring in.
So in chapter 1, we didn't talk about continuous variable. So continuous variable belongs to quantitative variable. So quantitative variable can be divided into two parts. It will be continuous variable and discrete variable. We will talk about this in chapter 2. So you know continuous variable is quantitative variable will be fine. All right. So continuous variable will be the numbers will be continuous. Discrete variable will be the numbers will be just the integers.
JUMP will decide on the basis of your modeling types what analyses are appropriate. So be sure to go through all of your columns to ensure that the modeling types are set correctly. Our second method is to copy and paste data from Excel into JUMP. To do this, I'll select the entire data table, including the column names, go to Edit, Copy, and then when I'm back in JUMP, I'll make a new data table using File, New Data Table, and under the Edit menu, I'll select Paste with Column Names. Pasting with column names will use the first row as the column names. If I were to paste without column names, I'll try this here with the new data table, JUMP will have as the first row the column headers. Notice that all of our columns are now marked as nominal because each column contains text. Be sure to paste with column names if you have copied them from Excel.
All right, so try these two methods to import Excel data into JUMP, right, using our data file or organics. Right, and next we'll talk about the data table.
In this video, we're going to explore the layout of JUMP data tables. I'm going to use the company's sample dataset available in the sample data directory. To get there, go to the Help menu and select Sample Data. To navigate directly to the companies.jump file, we're going to open the sample data directory, and I'm going to navigate to companies.jump. Click Choose, and the data table will open. In this video, we're going to explore the layout observations. Under the Tables section here, we see our file name, companies.jump, and we see any notes associated with this particular data table. If we double-click the notes, we'll see the actual text entered in there. Our columns.
So this information will tell you what? Will tell you when, where, how, right? So will be and why, right? The 5 W's, these ones will tell you who and what, and then you will have when, where, why, and how, right? So here will tell you the information about this.
This panel shows the columns in the data table. You'll see we have, in this case, 8 columns, 2 of which are nominal. That is the data type here. If I right-click, you'll see is selected to nominal, indicating that these are just labels for different observations. We have 6 remaining columns that are continuous. If I right-click these, you'll see they're marked as continuous, representing the fact that they're on an interval or ratio scale. They're actual quantitative measures. Under the Rows section, or the Rows panel, we have a listing of how many rows we have in our data set and how many we have selected. Notice if I select 4 rows, selected will result in 4. When we're in the Rows section, we can perform operations that either exclude or hide particular rows. If I click the red triangle here, which is where many options in JUMP will live, you'll see we can hide or exclude these particular rows. Hide and exclude will both hide the rows from any output and exclude their data in any calculations. If I go back to the rows dropdown, I can click hide and exclude again and return them to their original state. I can also hide or exclude only particular rows by selecting hide unhide or exclude unexclude. Columns have similar properties. If I select an entire column and go to the column section, you'll notice we can also hide or unhide a column. This will actually hide it from our data table, but not from the columns viewer. You'll notice you always have a listing of your entire columns in the column section. If I right-click the column again, select hide unhide, it returns the column to the data table. We can also exclude columns under exclude unexclude, which will, whenever we select a platform, not show that particular column in the listing. This is very helpful if you have several columns that are needed to perform calculations.
So for this part, remember for the identifier variable, remember that it doesn't have units, and this kind of variable is not for us to make the analysis about it, right? So for this case, you better to do this step to exclude this variable before you do the analysis, so that when you do the analysis, you do not have the variable in this list, right? It will not make you any mistakes. If you include that identifier, it will cause you a lot of trouble. Right, so this function is also
but you aren't using for your actual analyses. Gray triangles in the data table hide or unhide panels. Clicking the gray triangle here hides the left panel. Clicking it again reveals it. Clicking the gray triangle here hides the data table itself, sometimes useful when you're simply running analyses and don't need to see the raw data. Clicking it again opens the data grid and returns us to our original layout.
Alright, so is that easy? Right, in the end, the last one will show you how to save the JUMP results.
In this video, we're going to look at two different ways of saving JUMP results. First, copying and pasting to another program, and saving your work as scripts. I'm using the car physical data dataset available in the sample data directory. First, we're going to generate some output so that we can see how to save it to other programs. I'm going to use analyze, distribution, and produce a univariate output for two of my variables. I'm going to use type and weight. I'm going to drag type into Y and weight into Y. Clicking OK gives us the output for both of these different variables. Of course, they're on different modeling types, so our output is contextualized to meet the needs of each particular column. To copy output to another program, I'm going to use the selection tool, the fat plus sign. Once selected, we can select a piece of our output. I'm going to grab type here, and I'm going to use edit, copy. I'm going to switch to Word, and you'll see we're able to paste directly into the document our copied output. This will produce for tables the actual table output, including editable text, and for any graphical output, the actual graphic produced in JUMP. We can also save the script associated with this output to our data table, allowing us to rerun this script at any time. To do this, I'm going to go to the red triangle under Distributions, go down to Script, and select Save Script to Data Table. This will save the script for this particular output to my data table, allowing me to at any time click the red triangle and run the script again, which will produce the identical output as we originally produced. This script is stored as JSL, which, if you're interested, can be viewed by clicking the red triangle and selecting Edit. This allows you to modify the script if you need to select different columns, or if you are learning JSL, allows you to see how to call typical functions within JUMP.
Alright, so here I need to mention something about the save the script. Actually, for our report or any other computer lab, you cannot submit the script. Because what? Because this script is only saved to your own JUMP on your laptop, on your computer. right? So you cannot save it and then send the script to Canvas, and then I cannot open it because the original file is on your own computer, and I cannot open the script on Canvas. So to save your results or do any submission in the future, you need to create a Word file and then copy and paste your result to Word and then save the Word and then upload to Canvas. This is the only way I can view on Canvas. But this function is useful for your future research if you want to save your results instead of just copy and paste the pictures. Actually, you can save it on your own laptop, and then once you open this data file, you can click this script, and then your result will show up again. It will save you a lot of time, right? But not for our course because I cannot. The Canvas doesn't allow us to do this kind of thing. All right, okay. So I think today I just stop here and then show you how to import the data from the Excel, how to do something about the data table, and then how to save your JUMP results. All right, and then again in your modules, I just gave you a organics this Excel file. Right, so this Excel file is something like this. All right, so you will have 1, 2, 3, 4, 5, 6, 7 variables, and then these observations, many observations. All right, and I hope you can use this data table to import it into JUMP and then do summary about this data table, and then learn to do exclude, hide, and save your result and practice with this data file. All right, but I will not require you to submit any computer lab about it. I just hope you can practice with it so that you get familiar with JUMP, and in the future computer lab you don't get missed for these basic functions. All right, okay, so today we're done with the module 1, which is just a chapter 1. So actually chapter 1, I just want to give you a general introduction about what is business statistics, what is data, right? How we can deal with the data, what kind of results we can create from the data, right? So actually it's a lot of things. So until now, you should be able to know something general idea about the data, a general idea about the whole big things, and then from next chapter we'll do some detailed things about the data, right? So generate some graphics, right, and do some summary statistics about the data. All right, okay, so today